Hello everyone, this video is about the formula derivation of the differentiation. So if we have this is called differentiation from the first principle. So we have this curve, the function is y equals f of x, and let's say we want to find the gradient, the yellow gradient of the tangent here. So the yellow line is the tangent line and we're finding the gradient. So we can use this concept of secant. The secant is this red line crossing the curve at two different points. So at this point here, the coordinates should be x and f of x, x f of x, and at this point x plus h, f x plus h. So if we find the gradient of the secant, we get delta y over delta x. The delta y, the rise is the y2 minus y1, so f of x plus h minus f of x, and the delta x is x2 minus x1, so x plus h minus x, which is h, of course. So the gradient is this divided by this, f of x plus h minus f of x all over h. This is the gradient of the secant. To find the tangent gradient, we just have to use the smallest value of h possible, or when the h approaches 0. So we say that the gradient function, the f prime of x, is the limit as h approaches 0 of this gradient function, or this gradient of the secant. Actually here this is just y2 minus y1 over x2 minus x1. And for the polynomial differentiation formula, originally ax to the nth power, f of x plus h means we replace the x with x plus h, and we can use the binomial expansion, x to the nth and c1 x to the power of n minus 1 times h to the power of 1 and c2 x to the power of n minus 2 h to the power of 2 all the way to h to the power of n. Now using the differentiation from the first principle, the f prime of x is the limit of this whole thing here minus ax to the nth. So this whole thing minus ax to the nth divided by h. So when we divide by h, first of all, we have ax to the nth power, also ax to the nth power, they cancel out. So we only have the terms starting nc1 and so on. When we divide by h divided by h, they cancel out. So we have simply nc1 x to the power of n minus 1. And from here we have times h only, and all the way to times h to the power of n minus 1. So basically we still have h from the rest of the terms here, and the h is simply 0, the limit as h approaches 0. So here we can simply replace the h with 0, the terms go to 0, 0, 0, 0, 0. So all we have left is just the nc1, which is n, times x to the power of n minus 1. That's why we have this MF19 formula. Right, that's it. I'll see you again next time.